What if the universe is not slowly revealing its secrets, but suddenly accelerating the moment we are allowed to see them? The James Webb Space Telescope was built to look deeper, colder, and farther than any eye humanity had ever placed in space. But what it has been uncovering lately feels less like a collection of discoveries and more like a warning that our old picture of the cosmos was incomplete. It has seen water ice around young stars, strange chemistry around newborn planets, mysterious red objects from the early universe, unexplained formations on Saturn, new worlds around Uranus, and possible clues about habitability in some of the most promising exoplanet systems ever discovered. And the most unsettling part is that these are not isolated surprises. They are pieces of a larger pattern. Every time Webb looks somewhere new, the universe becomes stranger, richer, and more alive with possibility than we expected, as if reality had been waiting for an instrument powerful enough to expose what was hidden in plain sight. One of Webb's most powerful discoveries came from a young sun-like star called HD 181327, located about 155 light-years away, where a disk of debris is still surrounding the star like the raw construction material of future planets. This star is only around 23 million years old, which makes it extremely young in cosmic terms, almost like watching a planetary system while it is still learning how to become one. And inside that dusty disk, Webb detected crystalline water ice mixed with dust, especially in the outer regions, where more than 20% of the material appears to contain water ice in the form of dirty snowballs. That detail matters because water is not just another molecule in astronomy. Water is the chemical thread we follow when we ask how planets become habitable, how oceans may form, and how the ingredients for life can be delivered to rocky worlds during the earliest chapters of planetary formation. Closer to the star, Webb found less water, likely because ultraviolet radiation evaporates or breaks it apart. But farther out, the ice remains preserved, almost like a frozen archive from the birth of a solar system. This discovery suggests that water may not be a late accident, arriving only after planets are fully formed, but something present from the beginning, mixed into the very material from which worlds are built. And if water is already there during the earliest stages, then the path from dust to planets, and maybe from planets to life, may be more common than we once dared to imagine. But Webb did not stop at disks around stars, because it also detected a disk around a young giant exoplanet called CT-Cha, located roughly 620 light-years away in the constellation Chameleon. This was different because the disk was not only surrounding a star, but a planet. Webb's mid-infrared instrument revealed carbon-rich chemistry that appears distinct from the chemistry of the larger stellar disk nearby. In simple terms, the star's environment and the planet's environment are already evolving differently, even though the whole system is only around 2 million years old. That is astonishing because it means planetary chemistry can become complex very quickly. The raw ingredients around giant planets may separate, transform, and organize themselves far earlier than expected, revealing that planet formation is not a slow, simple process, but a chaotic chemical drama unfolding almost immediately after birth. Then Webb turned toward another strange category of object: brown dwarfs, sometimes called failed stars because they are too massive to be planets, but not massive enough to shine like true stars. Near one of them, Wolf 1130c, scientists detected an unusual amount of phosphine, a molecule that on rocky planets can be associated with biological or unusual chemical processes. That does not mean life has been found, and it would be reckless to claim that too soon. But the amount of phosphine near a brown dwarf is deeply puzzling, because scientists still do not fully understand what could be producing so much of it in that environment. Once again, Webb did what it does best. It looked into a place we thought we could categorize, and instead of giving us a simple answer, it handed us a mystery. Some of Webb's strangest discoveries have come from the distant early universe, where it spotted mysterious red points from the cosmic dawn that did not behave like normal galaxies or ordinary stars. At first, they seemed almost impossible to classify, but one leading possibility is that some of them may be hybrid objects, small black holes growing rapidly inside luminous envelopes that make them look almost star-like from a distance. If true, these strange red objects could help explain how black holes grew so quickly in the early universe, a question that has disturbed astronomers since Webb began finding massive structures far earlier than many models expected. Then Webb turned closer to home and aimed its instruments at Saturn, where, near the planet's famous polar hexagon, it detected dark, bead-like features that scientists still do not fully understand. These strange formations may be connected to the interaction between Saturn's magnetic field, its rotating atmosphere, and auroral activity near the pole. But for now, they remain mysterious enough that researchers want to observe them again during the equinox to see whether they are temporary or long-lasting. And then came Uranus. Webb observed the ice giant and detected something so small that neither previous telescopes nor even Voyager 2 had seen it. A tiny new moon estimated to be only about 10 kilometers wide, orbiting the planet with precision. That single discovery says something powerful about Webb. It does not only see the edge of the universe, it also finds hidden objects in our own cosmic backyard, proving that even in the solar system we thought we knew, there's still worlds waiting in the dark. The most emotionally powerful part of Webb's recent work may be its continued study of the TRAPPIST-1 system, a remarkable family of 7 Earth-sized planets orbiting a red dwarf only about 40 light-years away.